So I'm just going to run an example of how we can create an exponential model in the form. So we want to create an exponential model in the form y equals a e to the kt. Okay, and we're just going to be given some data and we have to try and create a model from there. So for question 11, we have a zoo that's releasing animals and it gives a function. The release rate with respect to time equals a e to the kt. So we've seen that before. It gives us some data. It says at the end of the first year, the zoo, so r of 1 equals 6. No, that's wrong. Oh no, that's r of 1. And r of 3 equals 20. And that is all the information that we need to solve this. Now this is going to be a version of simultaneous equations because we have essentially a y value, an x value, and we've got two unknowns. So we need to find the value for a and k. So the first thing we should do is substitute some values in. So r of 1 is 6, so we know that 6 equals a e to the power of k times 1, which means a e to the k equals 6. We're going to call that equation 1. And for equation 2, we know that 20 equals a e to the power of 3k. So we can call that equation 2. So we've got equation 1 and equation 2. We probably need to do some rearranging, which I'm going to do here. I'm going to divide both sides by, which one will I adjust? Let's adjust this one here. We'll divide both sides by ek. That's still equation 1 though. So now, over here, I'm going to have sub 1 into 2. So 2 was 20. Equals a e to the 3k. I'm going to replace a with 6 over e to the k times e to the 3k equals 20. I can cancel my e to the k with one of my k's up here. And now I've got 6 e to the 2k equals 20. Divide both sides by 6. E to the 2k equals 10 over 3. ln e 2k, it's that log law in one hit, I'm not doing it in 2 this time, equals that. We know we can cancel an ln e and divide both sides by 2. So we are left with k equals ln 10 over 3 divided by 2. Now we've found our k value out, we need to find our a value out. So to find our a value out, I need to sub this value into one of my equations. I might shove it into this one here because it looks a bit easier. So I'll do that. I'm running out of room, but I'll just move the camera a little bit for me. Do that over there. Maybe I'll do it over here. Do it over there. So I'll do it over here, which means I have 6 equals a e to the power of ln 10 over 3 divided by 2. A equals 6 divided by e to the power of ln 10 over 3 divided by 2. And I could shove that in my calculator and get an exact answer, which means my function RT, I probably shouldn't shove it in my calculator, I'll get an exact value. I'm being lazy. ln 10 divided by 3 divided by 2. So I get A equals 3.29. So RT equals 3.29 e to the power of, what did I say? ln 10 divided by 3 divided by 2 e to the power of 0.601, not 02. See. So that's the representation of our function. All we've done is take our general form, shove in information we know, use simultaneous equations, and find our two unknowns K and A, and then shove them in. If this was done in a tech-free exam, you could leave them in that form. If it was a tech-active exam, you'd probably use your calculator to solve those values. Hope that helps.